Welcome back. So you've prepped your data, you've chosen your model, what's next? Well, this is it. In this chapter, we're diving deep into the engine room of fine-tuning, the training setup. This is where all the theoretical stuff becomes real.
And honestly, that is not an exaggeration. This whole stage is about building the perfect environment for your model to learn effectively. You get this right, and your model absolutely thrives. But if you get it wrong, well, you're basically just burning through very expensive compute time. So let's get into it.
So here's our game plan. We're going to start with the overall blueprint. Then, we'll get our hands dirty configuring the training environment itself. After that, we'll tackle the fine art of setting hyperparameters, pick the right engine, that's our optimizer, and finally, I'll share some crucial tips for avoiding the most common roadblocks.
First up, let's talk about that blueprint. The key thing to understand is that a successful training setup isn't just one single thing. It's a process built on 3 core pillars that have to work together perfectly.
I like to think of it this way. First, you build the arena where your model is going to train. Second, you set the rules for the training game. And third, you hire the coach, the optimizer, that's actually going to guide the model to get better and better.
All right, let's dig into that first pillar, the training environment. Before a single bit of learning can happen, we have to build that arena. And the foundation of any good arena is the hardware.
Look, training these huge models is an insanely demanding job. You need some serious firepower, like NVIDIA's A100 GPUs or Google's TPUs. But it's not just about the raw processing speed. You also need a ton of VRAM, that's the GPU's own memory, to even load the model and your data. And seriously, don't forget about cooling and power. These things run hot.
But great hardware is nothing without the right software stack on top. This all starts with a deep learning framework, probably PyTorch or TensorFlow. Then you have GPU accelerators like CUDA and QDDN, which are what let your software actually talk to the hardware efficiently. And to make all our lives way easier, there are incredible helper libraries like Hugging Face's transformers that handle a ton of the complexity for us.
Okay, our arena is built. Now it's time for Pillar 2, defining the hyperparameters. These are basically the knobs and dials you get to turn before the training even starts. They control the entire learning process.
Now, let's focus on the big 3 here. The learning rate is all about how fast the model learns. If it's too high, the model gets unstable and can't settle on an answer. Too low, and the training will take forever. Then there's batch size, how much data the model looks at before it updates itself. And finally, epochs tell the model how many times it needs to go through the entire data set. Getting this balance right is everything.
So that's the big question, right? How in the world do you find the perfect settings for these dials? I mean, you could just guess and check, but that's a recipe for wasting a lot of time and money. Luckily, there are automated ways to do this, and we call it hyperparameter tuning.
Here are the most popular strategies. You've got grid search, which is the brute force method. It tries every single combination you give it. It will find the best one, but it's incredibly slow. A smarter way is random search, which just tries random combinations. It's way more efficient, but you might miss the absolute best settings. And then you have the really sophisticated approach, Bayesian optimization, which actually uses probability to predict which settings are most likely to work best.
Okay, on to our final core pillar, the optimizers. If hyperparameters are the rules of the game, the optimizer is the engine that actually drives the learning process, pushing the model to get better with every single pass. So what does an optimizer actually do? Its entire job is to minimize what we call loss, which is just a fancy word for how wrong the model's predictions are. It figures out which direction to tweak the model's internal wiring, its weights, to get just a little bit closer to the right answer, over and over again.
And you can really see how far we've come with optimizers. We started with something pretty simple called stochastic gradient descent, or SGD. It's really fast because it updates after seeing just one example, but that can make the learning process super noisy and unstable. Fast forward to today, and we're using incredibly advanced optimizers like AdamW. This one is smart. It adapts the learning rate for every single parameter and even has a built-in mechanism to prevent overfitting.
Okay, so we've got our 3 pillars, environment, hyperparameters, and optimizers. Sounds straightforward, right? Well, in the real world, things rarely go that smoothly. Let's talk about the common pitfalls you're likely to hit, and more importantly, how to get around them.
Trust me, you are almost guaranteed to run into some of these. Getting your hardware and all your software to just cooperate can be a total nightmare. Finding that just right learning rate can feel more like an art than a science, and you will always be playing this delicate balancing act between your batch size and how much GPU memory you have.
But hey, don't worry. The great news is you're not walking this path alone. These are common problems with well-established solutions that the community has figured out over the years.
So here are the real keys to success, the best practices you should absolutely follow. Start with a pretty low learning rate. Save your model's progress constantly with checkpoints. Use a technique called early stopping so you don't overfit. Definitely use those automated tuning tools we talked about. And a pro tip, use mixed precision training. It's a clever way to save a ton of memory.
Whew, okay. That was a ton of information. Let's boil it all down and wrap it up with a quick, actionable checklist.
So, step 1, build your arena. Get that hardware and software configured. Step 2, set the rules of the game with your starting hyperparameters. Step 3, tune those rules to find the sweet spot. Step 4, fire up that learning engine by choosing a modern optimizer like AdamW. And finally, step 5, keep a close eye on everything and apply those best practices.
And really, that's what it all comes down to. A solid training setup isn't just a nice to have, it is the absolute backbone of any successful fine-tuning project. You get this right, and you've set yourself up to build something truly powerful.
So, you know how to build the arena and set the rules. But what are the actual strategies you use inside that arena? Well, in our next chapter, we're going to explore some amazing techniques, like LoRa and other cutting-edge methods. Make sure you're subscribed so you don't miss out. Thanks for watching.